Hi, and welcome back, everybody. We're continuing with Chapter 12 on climate and climate change, and we've talked about some of the causes of climate change and some of the forcings. And now we're going to be talking about some of the effects that global climate change actually has. I think some of them are obvious, and some of them are going to be a little bit less obvious, but that's why we're going to talk about them here. So, global warming is something that occurs naturally, but a large part of it, we believe, is due to human activity. Human activity increasing greenhouse gases in the atmosphere. Greenhouse gases being the ones that trap in heat that the Earth is trying to reflect back out to space from the sun, but they hold it in. So that means the temperature of the Earth starts to increase. Over the last 100 years, it's gone up about 0.8 degrees Celsius. That's about 2 degrees Fahrenheit. All right. I'm sorry. I'm kind of doing it off the top of my head. About 1.5 degrees Fahrenheit over the past 100 years, which doesn't really seem like very much. But if you talk about the whole Earth, that's a lot of extra energy in the Earth that's in the atmosphere that wasn't there before. And again, we believe this is because of human activity. All right, and the climate models that we've created that kind of figure out what the climates were like in the past and kind of project what they're going to be like in the future, almost all of them say that this trend is going to continue. It's going to continue to get warmer, possibly get warmer at an even faster rate, that is, accelerate. All right, so the effects of this we really need to anticipate so that we can be ready for them, because this problem is not going to go away overnight. So here's a quick graphic of the various parts of the Earth that will be affected if climate change continues to take place. You've got coastlines, so that's outlined in red right here. Coastlines that'll be affected by rising seawater. You would think all coastlines would be affected by that, but these in particular are coastlines that have low-lying, that they don't have much elevation. And so as sea level rises, those coasts would really get affected by the rising seawater. All right, we've got ice melt. So wherever there's a little snowflake here, you've got ice melt from glaciers, and of course Greenland and Antarctica have glaciers that could expose bare ground if they continue to melt. The little blue raindrops right here is extra precipitation. The spiral thing, or like the hurricane symbol, is extra storm intensity. Of course, rising temperatures will take place all over the Earth, but especially in certain parts of continents, especially interiors of continents, you'll have rising temperatures over the course of a year. Pink dots are droughts and also wildfires as well. All of these are potential effects as a result of global warming and climate change. So one of the main things that's going to happen if the temperature of the Earth continues to rise, which it will, is the melting of glaciers and sea ice. Glaciers are large rivers of ice, you might think of them as, that generally exist on land, in mountain valleys, and many times they actually carve out mountain valleys, but they exist up on the land. All right, as they melt, that water is going to move and run downhill into the oceans. Also, sea ice as well, like icebergs and stuff. As they continue to melt, the water is just going to go into the ocean too. So there's some immediate problems that this presents, and that is communities that are dependent on snow melt for their water supply. If you've got communities up in the mountains, you can't necessarily drill down into the water table to get water. In many cases, they're dependent upon the seasonal snow melt to give them their fresh water that they use to live. Well, if this snow all melts and goes downstream, and there are no more glaciers uphill from them, these communities will suffer. In many cases, ski resorts have actually shut down as a result of decreased glaciers and not enough snow up in the mountains. It's even possible that Glacier National Park, now this is up in Montana. Some of you may even have visited this at one time. It's up northern Montana, close to Canada. Montana, close to Canada. It's possible that many of the glaciers in Glacier National Park may be gone by the year 2030. That's only 15 years from now as a result of this. So that would be a real sad thing, because the namesake of a park would actually have gone away. And we'd like to be able to prevent that from happening. Even the Alps, the European Alps, there are glaciers up in the Alps that could be gone by the end of the 2000s. So big impacts that global warming would have on glaciers and sea ice. Here is a Greenland Ice Sheet. So these are glaciers up here, and all this is just water charging off. Now, you don't see it melting from above. As the ice melts, water kind of runs down through crevasses and stuff, and then much of it runs out from below. So every now and then you'll see the water kind of spilling out from underneath maybe an opening in the ice, but in most cases it runs underneath the ice, so you can't actually see it. But when you do see it, kind of exposed at the surface right here, it's a lot of water all at once, and so it makes you realize how much of it is actually melting. So every year on Greenland, with the seasons, the ice melts and then it refreezes during the winter and so on and so forth. But unfortunately, every winter it's been melted more and more. All right, so in 1992, it melted down to this kind of faint pink line right here. Well, 2005, it melted down to this darker red line right here. So where the ice sheets retreat gets further and further back every year, and just another indication of global warming. Here's a very, very telling picture. This was shot, I'm guessing, maybe in the early 20th century or mid 20th century. Black and white photo, and all this is one big glacier, big river of ice that actually carved out this valley right here. Well, now the glacier is the head of the glacier is way back up in here, and all this is simply water or a lake. So that shows you how much ice, a lot of ice, a large volume of ice, has simply turned into water and has run downstream. So this melting of sea ice and of glaciers is actually an example of what I mentioned before in a previous section called a positive feedback cycle. Now positive, don't think of that as being like positive, good positive, but positive meaning increasing positive. And what that means is the effect of global warming it increases itself because as we know, snow, which is colored white, and ice tends to reflect radiation because it's light, and so it keeps temperatures low. But as global warming takes place and ice melts, all right, darker ground is exposed. All right? Darker ground doesn't reflect light as well. And so that darker ground absorbs energy from the sun, heating it up, which causes even more ice to melt. And so that causes more dark ground to be exposed and so on and so forth. So we call this a positive feedback cycle. Not positive because it's good, but positive because it keeps increasing. It just sort of accelerates itself. It's like a self-perpetuating cycle. Every year when we look at Arctic sea ice in the Arctic Ocean over the North Pole, every September it's at its minimum, all right? So it's the least amount, and so it should start coming back after September. But every September, it's been 10% less every single decade. Not only that, but the ice is also thinner as well. It's not as thick, and so it stores less water. And so where does all that water go? Into the oceans, driving sea level up. Take a look at this. 1980, all right? So I was a very young kid at that time. Right here is the minimum extent of the Arctic sea ice, just barely covering over the Arctic Circle. 2012, that's what, 32 years later. This little bit right here. So that's about probably less than half of what was originally right here. So a heck of a lot of less sea ice at its minimum than there was 30-some years ago. Okay, since we know that storms and cyclones and hurricanes are fed by warm seawater, another effect of global warming is the fact that it may increase the frequency and also the intensity of storms. The more water and the more humid, warm air you have, the more intense the storm is going to be. And so low-lying coastal areas, remember I showed you on that map how the coastal areas are really at risk because of global warming and sea level rise. Not just because of sea level rise, but also because of the actual storms that threaten those coastal areas. Not only that, but there's other side effects as well. El Nino, which is a roughly every 10 years event, is a result of warm water in the oceans being where it shouldn't be, and we'll mention that a little bit later on. But what El Nino does, that is abnormally warm seawater in the Pacific Ocean, it causes all kinds of abnormal weather phenomena. You've got storms where there weren't normally, storms causing landslides. There's drought where there wouldn't normally be, drought causing fires. So all these things are byproducts of global warming, not just from a glacier or sea ice standpoint, but from the standpoint of meteorology. Okay, so a minute ago I mentioned El Nino. And El Nino is a Spanish term. It means the child, and that's because this phenomenon tends to take place around Christmas, and so it was named after the Christ child. But simply what El Nino is a weather phenomenon. What takes place is in the Pacific Ocean, especially the eastern Pacific Ocean. Normally, the water is the warm water at the equator is pushed towards the western Pacific Ocean. But every so many years, about every 10 or 11 years, El Nino it backs up. All right, and I'll show you that in just a second. I'll show you this graphic right here. Well, in fact, I'll flip there right now, and then I'll come back. All right, normally, so here's the western Pacific Ocean. Here is the eastern Pacific Ocean, the Americas. All right. Normally, the warm seawater is over in the western Pacific. But every so many years, when an El Nino event takes place, this warm water drifts back towards the other side of the Pacific Ocean. All right, there's certain winds that normally keep it over here, but those winds decrease, and so the water kind of slides back towards the eastern Pacific. What that means is there being warm water right here where there normally isn't. It means that it throws all kinds of weather anomalies our way, not just in the Americas, but all over the world too. So this abnormally warm seawater can really wreak havoc in terms of meteorological events. So you can imagine how global warming would really just increase the effects of El Nino. Let me go back here a second. All right, so on a global scale, this takes place. There's also kind of an opposite form of that called La Nina, which means the little girl, but it's just another event where there's cooler than normal seawater in the Pacific Ocean. But it's really El Nino events that have the biggest impact. And so global warming, causing ocean water to not just rise up but also warm, can increase the effects of El Nino. Okay, here's another map, all right? So this dark red right here, like I showed you, is abnormally warm seawater, all right? So normally the warm ocean water is over here in the western Pacific, but when it drifts back over towards the eastern Pacific, up against North America and South America, warmer than normal seawater, which means it creates all kinds of interesting things along the west coast of North and South America. You have areas impacted by floods. That's purple right here. Why is that? Well, because it rains more than usual because of this warm, humid air just off the coast in the ocean. It also means that places that normally get lots of rain, like Indonesia and like the eastern part of Australia, are affected by drought because the warm ocean water is not where it normally is. So it really throws off the balance of all of meteorological events all over the world, especially around the Pacific Ocean. Now, there are other patterns, naturally occurring patterns, which, by the way, El Nino is naturally occurring. But there are other patterns that also do cause climate change on kind of a periodic basis. And so this term right here, decadal, just means on the scale of a decade, all right, over the course of a decade, which El Nino is about that much. Maybe a little more, maybe a little bit less. But of course, but an oscillation means something that goes back and forth. So decadal oscillations really mean patterns that, meteorology patterns that fluctuate back and forth over the course of maybe 10 or so years. All right, so it can cause weather to be more intense in some areas of the Earth and less intense in other areas. But there's a few that we're going to mention right here. The PDO, the Pacific Decadal Oscillation. All right, the Arctic Oscillation, the AO, the North Atlantic Oscillation, NAO. All right, so in the Pacific, warm water, kind of like El Nino, warm water being where it normally isn't, and cool water being where it normally isn't, can really affect climate and weather all over the world. Also, the Arctic Oscillation and the North Atlantic Oscillation. They cause what you may have heard of the polar vortex. All right, that is extra cold air coming down from the North Pole and affecting our climate. So all these oscillations do take place naturally, and in some way they can affect the climate more than human-caused global change, but they kind of go back and forth over the course of 10 years. What humans have been doing is causing the climate to simply increase in temperature because of putting greenhouse gases into the air. So you can see from this kind of graphic right here, the Pacific Decadal Oscillation, all right, where it's where it's kind of lower than normal and higher than normal here, and then in the opposite phase, it's higher than normal here, and then lower than normal right there. So, and you can see even temperature-wise how this kind of goes up and then down, and then up and then down and stuff. So naturally, the temperature does fluctuate, the climate does fluctuate up and down, but not in the same way that humans affect it. Okay, so what are some other effects of possible effects of climate change? Well, the effects of precipitation. We certainly depend on precipitation to grow crops and to be able to have agriculture that is productive. All right, so that's going to affect rainfall patterns. Like I mentioned, El Nino, which is kind of a small-scale climate change or a periodic one, that really causes extra rain where we don't normally have it and extra droughts where we don't normally have it. If that happens permanently, then there will be areas in the world that are just no longer productive for agriculture. Good news is northern Canada and Eastern Europe may be more productive than normal because they would get more rain because they're actually at higher latitudes, less affected by the sun. But places closer to the equator are going to become more arid, more dry because, of course, that's warmer, and so it's going to be harder for precipitation to fall. All right, not only would agriculture be affected, but also just the availability of water. All right, so hydrologic changes. That means that the ability to have just water, whether to grow food or to produce food, could really possibly affect food supplies worldwide. I mentioned less water already for fruits and vegetables, of course, and also in terms of water just to drink. In the winter, it would rain more in the winter, which sounds good, but we're used to having more snow in the winter. And so places that depend on snowpack in the mountains, having stored water up there that runs down over the next few months, that water would run down right away because it's not snow, but it's rain. And so that would be a limited supply of water that those people would have. So all these things are negative connotations of climate change that is affecting precipitation negatively. Okay, so we mentioned before how melting glaciers and melting sea ice is bad for those areas that depend on snowpack and stuff. But now, of course, there's the problem of sea level rise. All right, well, not only is the water running into the oceans, but if the oceans are getting warmer, well, the warmer water, the higher temperatures, that means water expands. All right, water that is warmer expands a little more, and so that causes the sea level to rise even more. So between this, all right, and between melting glacial ice, that means that in the past couple decades, that's been the majority of sea level. It's been the majority of the cause of sea level rise since the mid-1900s. All right, so with the models that we have, the climate models we have kind of some predicted or estimated sea level rise, but there is the problem is that the actual sea level rise is very different. So the difference between what we predict and what is actually happening is quite considerable. It's a big difference. So that means we need more research to be able to accurately predict, how high the sea level is going to rise and what the effects are going to be. Even so, there's no doubt that the melting glacier ice and the thermal expansion, that is the expansion of the water, is accelerating. It's not slowing down. And it's only going to become a bigger problem in future years and decades. Now, the big part of this is the Greenland Ice Sheet. All right? All the ice that is up on Greenland is melting and running into the oceans. And this is causing a major problem for sea level rise globally. What effects could this cause? Well, coastline erosion. All right, the higher the coastline, the more structures and the more coastal features are going to be eroded and vulnerable to waves. It also means the estuaries, that is, water that runs into the ocean, is going to have to migrate towards the land because, let's say you have a coastline right here, and here's a river running into the coastline. All right, well, if that coastline starts advancing, all right, towards the land right here, that means that's going to force that estuary, that is where the fresh water meets the ocean, it's going to force that back landward right here. Here, by the way, I should have drawn this a little bit better. Here's the ocean. Here's the water out here. All right, and so the other one is the land. So as the sea level tends to approach or move up onto the land, those estuaries get forced back up onto the land as well. We talked about tropical islands in the Pacific Ocean. All right, Tuvalu is already threatened by sea level rise, not very high above sea level, and the rising up could be the end of that island nation as we know it. Even Alaska, which is a large chunk of land, but we've seen that the coastline has been really, really rapidly eroded, also because of permafrost. That is permafrost in Alaska melting. A lot of that ice locked up in the soil in Alaska is now melting, is able to run out into the oceans. So all these things are factors that contribute to and also are results of sea level rise. Wildfires are another side effect of global warming. I mean, the more warm and arid areas are, the more prone they are to wildfires. And we've seen this in El Nino, kind of on a small scale, but it could accelerate in frequency and also intensity as global warming continues to take place. In terms of animals, we could have certain species really be threatened by sea level rise. We're finding even now that mosquitoes, which usually live down towards areas that are kind of swampy and stuff, they're moving to higher elevations because the sea level is rising up. Butterflies in Europe are migrating to where they weren't normally previous times. Forests in the Cascades are expanding. That is, they're changing their where they exist because of the change in global climate temperatures. Seabirds, walruses, and polar bears are all affected by sea ice. Keep in mind the polar bears, actually, many of them live on floating ice. They don't live on land at all. And so if this ice goes away, polar bears are going to have less place to be able to rest and rest from swimming through all the water. Coral reefs, we've seen in our coral reef video how bleaching has been taking place, not just in Florida, but all over the world. All right, and so all kinds of marine creatures that are even remotely related to the ocean are going to be affected as a result of global warming. Now remember that carbon dioxide, CO2, is one of the big players, the big culprits in global warming. That is, it's a greenhouse gas. The other thing about carbon dioxide is the fact that it dissolves very easily in water. You know this if you ever had a soda before. Carbon dioxide very easily dissolves in that, and what it does is it makes it slightly acidic, or in some cases very acidic. Soft drinks, sodas are very acidic. They can be very caustic, which is why you're recommended to not drink all that many of them. All right. Well, carbon dioxide in the air very easily dissolves in the ocean, and so the ocean water itself becomes more acidic. It's really increased a lot just in the past 15 years. So what that means is for organisms that depend on being able to create shells, especially shells out of calcium carbonate, they're going to have a more difficult time with that because calcium carbonate reacts with acid, all right, dissolves it. If you combine vinegar, which is an acid, with baking soda, which is a carbonate, it fizzes up and it dissolves the baking soda. Well, that same thing is true of marine organisms that create shells. That means shellfish. It also means coral as well. So they're going to have a much more difficult time maintaining the acidity, the required acidity to produce the shells to build their homes. So even ocean acidification has really become a problem as a result of extra greenhouse gases in the air. I'll let you take a look at this on your own, but this is really just a graphic that talks about how atmospheric carbon dioxide is being absorbed by the water and causing effects in the ocean. And not just animals themselves, but whole ecosystems can be affected by the impacts of global warming, especially in North America. Precipitation will be thrown out of balance, all right? Less frequent, but more intense instead of less intense and more dependable. Streams and rivers, temperatures are going to increase. You're going to have more wildfires. The growing season is going to be long, and so there'll be less winter and less snowfall, so less snowpack as well. Species moving to higher altitudes. So all these things are impacts that entire ecosystems will suffer because of global warming. And so this affects millions and millions of different kinds of animals. So are animals just victims of this and can't do anything about it? Well, no. They actually do adapt to global warming. In many cases, what they do is they migrate. They shift their ranges in most cases towards the poles where it's more temperate because the equator is getting warmer and warmer. So plants, what they do is they bloom earlier because of global warming. Frogs breed earlier, and birds that migrate, they move back and forth earlier. And so we have animals shifting around, which sounds like it's a solution to the global warming problem, but it's actually throwing ecosystems out of balance. So all these things are effects that global warming has and are negative effects that we need to somehow mitigate and deal with if we don't want to see our Earth change as we know it. So that's going to be section 6. I'm going to stop there for now. Thanks for following along, and I'll see you on the next one.